Have you ever just wondered how we actually know things? How we go from a nagging question about a problem to a real solid answer? Well, that's exactly what we're diving into today. We're going to go on the researcher's journey to understand how we find reliable answers to some of our most complicated questions.
I mean, just think about the world around us. We're surrounded by these huge, complex issues, right? Things like road rage, or cyberbullying, or even just the impact of social media on our own well-being. These aren't simple problems you can solve overnight, so where do you even start? How do we get past just seeing these things happen and start to really understand what's driving them?
Well, the answer is all about a process of discovery we call research. It's really our most powerful tool for digging into the world around us. It's how we turn that simple, everyday curiosity into real, actual knowledge that we can use.
So, to guide us, we've got a bit of a map for this journey. First up, we'll nail down what scientific research even is. Then we'll get into its main goal, which is this big idea called generalization. After that, we'll look at the different tools a researcher might use, we'll cover the rules that make research trustworthy in the first place, and finally, we'll see how all this new knowledge actually makes a difference in the real world.
Okay, so first things first. Every great quest needs a really clear goal, right? So before we jump in any deeper, let's get on the same page about what we're actually talking about when we say scientific research. Now, look closely at that definition. The most important word in there for me is revision. See, real research isn't about just collecting a bunch of facts that prove what you already think is true. No, it's a dynamic process. It's about challenging what we think we know. It's about being open to finding something new that might completely flip our old ideas upside down.
And you know, this process isn't just a random walk in the dark. It follows a very clear, structured path. It's almost like a detective solving a crime. You start with the mystery. That's your problem. Then you look at the old case files. That's the literature review. You come up with a hunch, your hypothesis, and then you go out and find new clues and evidence. Every single step builds on the last one, which is how you end up with a conclusion you can actually trust.
Okay, so we've got the what and the how of research. But what about the why? What's the big prize at the end of this whole journey? Well, it's this really cool thing called generalization. Think about it like this. If a scientist only studied one apple falling from one specific tree, their findings wouldn't be all that useful, right? The real magic of research happens when we can go from that one single event to a bigger, more abstract idea, like the concept of gravity, which explains why all apples fall.
And that's the whole point. The goal is to create a generalization. It's a conclusion or a principle that doesn't just apply to that one apple, but to a whole bunch of similar situations. It's about finding the bigger pattern, not just a one-off fluke. That's how we build knowledge that's actually useful to us.
So what does this new generalized knowledge actually do for us? Well, a few things. It can push the boundaries of what we know into brand new territory. It can also act like a course correction, fixing something we've believed for a long time that turns out to be wrong. Or it can help verify what we already thought, giving us more confidence that we're headed in the right direction.
All right, now you can't answer every question with the same method. It's like being a mechanic. You need a whole toolkit. And a good researcher knows that picking the right tool for the job is absolutely critical.
So, two of the biggest tools in the box are qualitative and quantitative research. Think of qualitative as the why research. It's about deep dives, like doing long interviews with people to really understand their personal experiences. On the other hand, quantitative is all about the what and how many. It uses numbers and stats to find broad patterns, like surveying 1,000 people to get the hard data.
We can also split it up another way. Descriptive research is kind of like being a wildlife documentarian. You just observe and report on the world exactly as you see it without getting involved. But experimental research, that's more like being a chemist in a lab. You actively change one thing, a variable, to see exactly what effect it has on another. It's really the gold standard for figuring out cause and effect. So, you've picked your question, you've got your tools ready to go, but to make sure your results are actually trustworthy, you got to follow some essential rules of the road.
You can think of these as the absolute must-haves for any good piece of research. You need a super clear goal. Your process has to be so detailed that someone else could come along and do the exact same thing. You've got to try to be as objective as possible and be totally honest about any potential flaws. And maybe, most important of all, your conclusions can only be based on the data you actually found, not what you hoped to find. This kind of rigor is what makes science, well, science.
Okay, we're at the final stage of our journey. We've gone out, we've done the work, and now we have this new, solid, rigorously tested knowledge. So, now what? What do we do with this treasure we found?
Well, this new knowledge usually heads in one of two directions. You've got basic research, which is all about curiosity. It's about expanding what we know, just for the sake of knowing it, like an astronomer mapping a distant galaxy. Then you have applied research, which is all about solving a specific practical problem, like an engineer trying to build a safer car. One is about knowing, and the other is about doing.
But here's the thing, and this is so important. These two are not enemies. They're actually part of a cycle. This quote says it all, really. Sometimes the most abstract, useless theory can end up having incredible real-world uses years later. And sometimes trying to solve a really practical problem leads you to a massive theoretical breakthrough. They're constantly feeding each other.
So, at the end of the day, research is an incredibly powerful tool. It's like a double-edged sword. It can be used to build a better world, but it can also be used to cause a lot of harm. It's given us life-saving medicines and incredible technologies, but it's also given us terrible weapons. The tool itself is neutral. What matters is how we use it. So the final question isn't just about the how, it's about the why. What question do you think is worth answering?